Okay, I'm going to cover specifically the 7-hole plate. All right, so here's our print, but I'm going to go right to the plan, right? So right here is the project. So you got saw cut, not machining anything. We're going to deburr, we're going to use layout. So dike them and do that. Center punch the holes with punch and steel hammer. And I'm going to prep drill all 7 holes with a number 4 center drill. So you can do that all in one shot. Set the drill press at 1,000 to 1,500 RPM. So walking around and spotting all the holes. So you want to get good, enough that the drill has a little bit of the cone in there of the center drill. Then we're going to drill all 7 holes. We're going to do this in steps. So they're all prepped. And once you drill a pilot hole, all the holes should follow that. You know, even if they're not quite aligned, they'll self-align. So according to print, it says drill 3 left-hand hole clearance holes through per print. So per print, it's 0.265, 0.328, 0.390. So if I go to my stare at wall chart, I'm going to go figure out which drill I'm going to use for that. So I go get those 3 drills, and I can do them in order so I don't have everything mixed up. And if I pre-measure them and then put them down, I can probably clearly see that they're 3 different sizes. So that'll take care of those 3. All right, then we get the middle row, center row. We got 2 holes that are reamed and 1 that is threaded. So in this case, the 0.251 and the 0.2495 are going to be reamed. In the previous video, I talked about how, why and how of reaming. And the middle one, it says 5/16-18, that's threaded. That's it. And all these holes are through the plate because it's a very thin plate. All right, so back to the process. All right, it says drill 2 reamed holes, 1/64th undersize. In other words, 0.234 diameter. So it's going to be less than 250 or 251. All right, so that'll take care of drilling that. And then the middle hole, which is the threaded hole, 5/16-18, we're going to look on the wall chart, but right here I'm telling you to use a 0.257 drill, letter F. So the same thing, you don't want to mix up the drills. You want to get the right drills in the right holes. So the 2 outer middle row holes will be smaller, slightly smaller than the middle hole. So that'll take care of 6 holes. Then we have to do 1 more hole, which would be the far right hole. And that's 328, which actually is the same diameter as the one on the far left. So I can drill all those holes. So all those holes will be drilled, all 7. I put in here 90-degree countersink on all holes using freehand method, top and bottom, see instructor. I'm going to say in this case I would do that at the end, so I'm going to probably reorder this, but I would probably go to step 3, which would be the final stuff, and countersinking we should do last. So we're going to go right to reaming. Half the speed, twice the feed. So we were drilling at 1,000, we're going to ream at 500. And ream 1 hole with a 0.251 reamer, which we're going to call the slip fit hole. And I'm going to ream the other hole with the 0.2495 reamer, which is the press fit hole. So when we go later on, we're going to go to the arbor press and press the pin in the press fit hole. Then we're going to put threads in the middle hole. We're going to get the tap out of the kit or the toolbox, and we make sure it says 5/16-18 on the side. And the same goes for the reamers. You need to identify and not mix up the reamers, because you can't even measure those with a caliper accurately. So you got to make sure that keep them in the proper boxes and in relationship. So the same thing with the threading, only we're going to use not totally freehand method, but we're going to use like the drill press spindle chuck or the milling chuck the drill chuck to help align our tap. I'm going to use a tap guide and a tap handle that has a little drilled hole in the top. And then we're going to check it with the checking screw, make sure that the thread goes all the way through. You want to test your thread afterwards. So there should be a 5/16 screw in your kit. The last thing we're going to do, a big thing, is going to be countersinking the big countersink, which is the 82-degree countersink. So you got to make sure it's 82 degrees, read the side of it. And if you don't have the screw handy, we're going to go countersink to approximately 0.68 deep, or if you actually scribed a circle, just keep on going until you get to the circle visually. But then we can check fit with a known screw, meaning that a flathead screw that would have to go in there. There's only one size screw that would fit in that. So make sure that's good, and you need to make the screw be flush. It can't be screw can't be up above a little bit. So proper way of doing it is flush or slightly below flush. Then we'll go back and do the 90-degree freehand countersinking on all the holes, or you can do the hand whirligig tool and clean up all the holes. And then we're going to press fit a pin, 0.250 pin in the press fit hole. But you want to check the other side and make sure it's a slip fit. And then we can dress them up. So there's a picture there of a 5/16 bolt, flathead screw. We got the pin, those are precision pins. They're exactly 0.2500, not 251, not 253, but 2500. And that thing is called an arbor press. That's for light, like what we call light press work, something that needs to be pushed into something. You can use a light hammer or a brass hammer, but getting it aligned is critical as far as assembly. So you want to press the pin in, and the whole point of pressing in the pin in is in the correct location, and the pin won't fall out. So if you were working on it like an engine, one side has a press pin and the other mating side would be a slip fit, and that ensures alignment. So that's really a sampling of holes. So anyway, a little talk about hole making and reaming and counter boring and stuff like that. Okay, thank you very much. Talk to you later.